Okay, it's time for part two of lesson 14. Here we go. And we'll do a little bit of review of what we did in part one. We talked about a concept of what could be done using 512K on your color computer. Lots of information. A lot of it was probably confusing to a lot of people. I showed examples of what I did on my system where a lot of things are available to use. Uh, Hope you didn't get disinterested, because if you really want to use the 512K, I think there's this part here will get you to using that concept and get there. Okay, so hopefully part two will help. We talked about a stub. Key to this whole thing is this stub program. It's like BASIC or OS 9 or any operating system, MS, DOS, Windows, mainframes, Unix, Android. Doesn't make a difference. They all have to have some basic program, which I'm calling a stub here, that is the traffic cop or the router to know what's going on and to get to all them resources when needed. It must always be in memory so you can get back to it at any time. Best work with our 512. It's not we only got 64K we can work with, and having this 512, we got to be able to swap things in and out. But that stub traffic cop always needs to be in memory. We use direct as to other feature functions, be able to bring other things in, whether it's sprites, graphic screens, calculation routines, etc., etc. And when all said and done, come back to it and it will clean up afterwards. Get back to where we started. In this exercise, we got two basic programs and two assembly language programs. The first basic program is called XBuff. It's going to load the two assembly programs, the stub and the main code. The second basic program, which I've named HBuff for whatever reason, it's going to be our main program. It's going to build our screen for us, and then it will allocate some three buffer spaces using the basics HBuff command. Will allocate three different buffers. It will get some input from the keyboard, validate that input, and it will call assembly programs to do the gets and the puts via the stub. It has to go to the stub to get this done. Okay, so the first program we'll run will be XBuff. It's going to load them two programs. The stub will go into low memory at E00. You can go anywhere you want it as long as it doesn't get swapped out. I just picked E00 for this exercise. If you wanted to keep it in memory for long term also, you could put it up around, I'm going to say FA0, up in that area. There's some open space up there that's not used, or in the D range, the top of the D range, there's some space in there. But for the next exercise, we're just going to put it E00. Our main program is going to go to the high end of the graphics screen, block 33, up at hex 9800. And I chose that for a very specific reason. It's something you normally wouldn't want to do, but it will give you an opportunity to see other ways of doing things. The second program was H program, the main basic program we're going to be running. It's going to give us our screen, H screen 2, 320 by 192, 16 colors. Draw a bunch of lines, vertical and horizontal, creates a bunch of boxes. We'll do some H paints to them boxes and some H prints some numbers in them boxes. It's still all basic stuff, and we'll allocate, like I said, we'll allocate three buffers. So I will take here and do a demo of what we're going to do so you know what we're talking about. Okay, I've already got that first program XBuff loaded, so I will run it. I think I got it loaded. All right, that's the stub loader. It's loaded a stub program at E00. The other one has been put up in buffer 33, and there's got a note there, do not do an HCLS. We'll talk about why later, and we'll get out of that. Then we'll run our second program, which is H. We'll run that one. This one takes a little while to load in because I've got it stored as ASCII and it's got a lot of comments and it's not compressed to be fast. And that is just easy for schooling purposes. They're drawing a bunch of lines. It's doing a bunch of paints, random color paints to these boxes and number them as it goes. It's going to do a 8 by 8 grid or 0 through 63 or 64 boxes. Okay, now it's got them on there and it's going to number for the first box. And for this, what we're going to do here, let's use box 1. Type in 1 and hit enter. For box 2, let's use box 63. And I'll hit enter. And it swapped them two boxes. If you look, 63 is up where 1 was, and 1 is down where 63 was. That's all this does. Not too exciting. That's what it does. Has a couple other options. I mean, you can just keep swapping around. 88 is a automatic. You don't have to type anything. It will do random stuff for you. I'll type in the 88 and we'll let it run there for, I think it does 100 iterations. It's just swapping two things back and forth. That's all. That's what we're going to accomplish with this. And remember, the stub program's in there. The program's actually doing his swaps is loaded up in my high memory. So let me get back out of this, if I may. Okay, so that was our demo. That's what we're going to do. I know you've seen this screen many times, but again, it's key to what we're doing. Let's talk about it one more time. Over here on the right is our memory, our 64K, 0 to FFF. That's what we operate out of. When you turn it on, you're in task 0. Here's what you got. You got your system and all your basics are loaded in. Here's the blocks it's using from hex 38 to 3F, 3F being 63. There's only 64 blocks in the system, okay, and that's block 63. Okay, it uses the upper 8 blocks. And here's the task registers, okay, using FFA0 through FFA7. We've been through that many times. If you say task 1, here's what you get. 64K is the same. I should have taken out the words extended basic and disk basic, but this is what we'll have it. These blocks stay in, 38 stays in, the system block, color basic stays in, and super extended basic stays in. 30 through 33 is our high resolution graphics screen, regardless whether you do an H screen 1, 2, 3, or 4. It uses them and they must stay together, contiguous, so for the MMU to be able to go to the screen. So that's what we have if you do task 1. So we're going to be moving our code up into this block here, and later on we'll be swapping this one out and putting something else in there. Okay, let's talk about the graphics area. It's blocks 30 through 33. When it's back up here, when it's swapped in, it comes in down here. You can see it 2000 and goes up through 9FFF. Okay, which again, this shows the same thing, 2000 to 9FFF. And we're really going to be working with block 33, what we're going to be doing. Okay, when we do an H screen 2, it is a 320 by 192 by 16 colors, I said, and it takes 7,800 bytes. Okay, where did I come up with that number? If you recollect way back when, I give you this copy of this. Here's H screen 1, 2, 3, and 4. H screen 2, if we look at that, okay, it's 320 192 by 16 colors. Then it uses 7,800 bytes of RAM. So that's where that number come from. So it will go from hex 2000 plus 7,800 up to 98 hex 9800. Okay, that's what it will, where that high resolution screen will be for H screen 2. Okay, here's another look at that block 33. It goes up from, the block itself is at 8,000 to 9FFF. The H screen 2 goes up to 9800, which is right, I'm saying approximately where this line is here. And so from 9800 to 9FFF is not used by H screen 2 or hex 800 or bytes are 2048 bytes. So we're going to put our code in there. Okay. Something you may not want to do, but just give you another idea of what you can do. I'll remember this exercise is for a concept and to get your memory juices flowing and say, okay, I understand that. Now here's what I might want to do. But we're going to put our code in there. Okay, how do we get our code in there? Okay, the very first basic program, which was XBuff that loads this in, he's going to do a peek at FFA2, get the current page and save that. Then he's going to poke in page 33, which is the page we want in the FFA2, and we'll load our main program in with an offset load of C00. Okay, I don't know if you understand that. Let's go back and look again. Here's where we're sitting at when that code runs. Our basic program is down here at 2600. We'll load our stub in here, and what we need to do is get our program at 9800. Well, we couldn't put it in there with a load M at 9800 because extended basics in it. We need to get that other block in there to put it in there. Okay, if we was to do a task 1, our basic program is gone, so that won't work. So we've got to be able to bring that block in somewhere here in this open area. Well, our basic program's here. Basic will not let you change this block number. Believe me, try it. You try it. It won't will let you let that block. We could use either one of these two. Problem with this one here at 6007 FF, our stack is in there. Now we could probably manipulate somehow our stack, but that's a lot of work in a basic program. So what really is available to us is FFA2 or hex 4000 to 5 FFF. Go back down here. Now we're going to load it into that area, FA2 at 4000 to 5 FF with an offset of C00. Okay, stick with me on this one here. This has been around since day one in Color Computer, way back when it first started. This had been able to do this offset. So our HBuff program is going to be at that 9800 I talked about. So we take our 9800 and we add C00 to it. It will give us a hex 15800. Or in 16 bits, we wouldn't have that one. We just have 5800. Okay, you have to do your own calculation where you're putting it. I'm just saying I ended up getting the calculation using C00, so it's going to put it in at 5800, our program. Again, we'll go back. We're here. We'll load our program at 5800 because with our block 33 here, we'll put it at 5800. Okay, so that's where it's loaded. When we do a task 1, that block's going to come in where, guess where? Up here. Is it come in here? And it will be at 9800 when it comes back in. Okay, it doesn't make any difference. If you bring it in here, it'd be at B800. Here it's going to be at 9800. It's just, we're loaded at this address. This address, it becomes 9800 where we want it. That's where our code is. Oops, I went too far. So that's how you get these programs loaded with offset. And then when that's done, we'll restore what we saved up here, FA2, and we're back to normal. Okay, now it's time to look at some. That's hopefully not too confused. Now we need to look at some. Let's look at some code. Okay, here's that first program. This is the XBuff one. This one here does the load I just talked about. Okay, it just gives us 80 character screen. It says H screen 2. It sets up a bunch of stuff for basics to know what we're doing. We'll do a clear screen and we'll go H screen 0. That takes us back to 80 character screen, and we'll clear that screen. And we'll print some stuff there. Stub loader. We'll do what we just talked about. We'll load that programs up there with the offset, and then we'll also load our stub program at E00 and print some stuff on the screen. That's all that program does. That's just get the system loaded up for you. Next thing is our main basic program, or HBuff. Okay, again, it has a whole bunch of stuff in here. I'll try to get through this here. Okay, back in, I guess, lesson 12, we talked about how do we to find users and how do we get to all these different routines. We could do executes, but again, I do it in a common fashion that's I can change programs, and once this stuff becomes static, my init routine is always going to be able to address at E00. It won't, the routine won't be, but the address where the routine will be at E00. The HGet1 here is always going to be at E003. Not the code, but the address where I can find it, and so on and so forth. It gets in the puts and the clear screens. Okay, we're going to define all them, and we'll look at them later. We're going to do a poke here, way up at high memory and super basic opcode for a branch never. We're going to put that in there. We do not want basic. When you say H screen 1, 2, 3, or 4, it does a clear screen of that whole area. Remember, we looked at this, had blocks 30, 31, 32, 33. Regardless what size memory, it clears them blocks out. There's no clear half of a block or anything. It clears out. We don't want to clear a block. We just put our code in there. So we're going to do instead of, we change the branch subroutine to a branch never for this exercise. Now, we've got a bunch of variables that we put in here for different, where these blocks are on the screen, left and top, right and bottoms. Okay. Set up a border color. Do a sub down to bottom and set up the palette like we've done in other things, the standard way we've been setting them up for over a year now. And here's our first going away from here to user 5, which is a clear screen. We'll go there later on. We'll look at that later on, but that's our first venture away from our basic program. Then we're going to go back into screen 2 mode. It will not clear the screen because we told it not to. We'll set our colors as background to black and the foreground is gray. That way our lines will be gray. Now we're going to draw a bunch of lines. Okay, and this is code you've probably done, drawing a bunch of lines. You can look at that and say, okay, yeah, that's good or bad. So it draws a whole bunch of horizontal lines, a whole bunch of vertical lines, and here we're putting in 2 lines side by side because it's 2 pixels wide, and we're trying to keep everything on an even boundary. Get through all them lines. We got our boxes, and then we'll go back to our background color of black and a foreground color of white for our lettering. Okay, now here we're going to work within them squares. We're going to do something here. It's an 8 by 8 grid, so we'll do that, and that's all this stuff here. We're going to get a random color. Make sure it isn't white, because white color but white letters, we wouldn't see it. And then we're going to paint in them boxes. Okay, I don't know if you use the paint command, but we're going to give it a point in the upper left-hand corner of the box. That's what we calculated here. The upper left-hand corner, use the color that we got as random, and the border is a stop color. When it finds that, it won't. Okay. This here, X0, this here, we want to right justify the numbers and what that is. Let's take one quick away from here. I like to, when you write, if the number is less than 10 or 0 through 9, right justify it, because it looked funny when, like, if this 1 was over here, it just looked funny, so I just added it for looks. And that will print the numbers in the boxes. So we're going to random colors, print the numbers in the boxes, and go through that loop 64 times. And then we're going to grab some buffers. We're going to allocate some buffer space. Okay, HBuff1, 200 bytes, 2, 200 bytes, and 3, 200 bytes. And this is used for blanking out messages. Okay, I'll better try to explain that. Here's our screen. You type in a box number, and it will print it to the screen. Just say you typed in 35, it would put 35 on the screen. And over here with this other box, we put in 45, it would put 45 in there. Well, the next time through this loop, in the graphics screen, there is no clear what I just printed to the screen. And if you try to print spaces, it's just orange stuff on there, and it's orange the background color, and doesn't do anything with the foreground color. And there's probably ways of doing it by changing the foreground background colors. But all I do is I'll take a pointer from up in this upper left-hand corner and go over like 20 pixels, down about 10 pixels and put that in a buffer. Oops. And then what I want to do is I'll just put that buffer out here. It blanks out with black. It's all that's doing. Nothing exciting, just to clear it out. If you don't, you just keep printing over the same thing. You can't read it. So that's what that did. We get the buffer, we'll save it, and now we're going to go off to our stub program, which is this is our defaults are our init routine. We'll look at them. I'm just going to get through this program here. We print the rest of the stuff on the screen, all the options, and here's our main loop. Our main loop is right here on this page. It's not very long. Go from there. Oops. If I can get from there down through there. That's the whole main loop of this program once we got it all set up. We're going to clear out the messages I just talked about. That's them two puts there. Ask for some input from the screen. Get our box number 1. All right, we get the box is 99. We'll go to 960, which is in the job. If we put in our 88, we'll go to that automatic loop routine. If not, we'll validate that it's in between 1 and 64. We'll check it right there. If not, we'll get new numbers. We'll take that input number. We'll make a variable out of it and a string variable out of it. Okay, and then we'll print that back to the screen. Like I said, if it was box 35, we'll print that 35 on the screen. And then we'll go back off to the stub program, which is going to take us to get buffer 1. And it will do its thing and then come back here. We'll get number 2. We'll do the same thing. Get buffer 2. Then we'll go back off to an H swap and put them back on the screen. Put 1, put 2. Back 650, which is the top of the loop, and just go through the loop and just keep going on through it. That's it, okay? The only thing we'll look at here is when we do our 99 into job, we're going to poke this hex BD back at that address, and we put that branch subroutine instruction back in there where we put the branch never. Okay, so that's all the stuff within inside this program here. Again, our routines are at E0, 3, 6, 9, 12, and 15. Okay, so let's go look at our actual stub program. Here's the stub program itself. A lot of stuff in here. Okay, well, includes. I've got them where it's not printing them out, but it was a common include we've been using forever. It's the same thing. In lesson 13, I presented a maclib. If you still got that maclib, that's we're including that. We're going to use some of the macros, and we got one for this series is hbuff.include, and here it is. I'm printing it out. So there's a whole series of stuff that's used for this program and the main program. There's just a lot of information. We'll get to some of it later on. We also have a structure that we talked about last time. We have a structure where this box information goes. And here's our program at E00. Remember we just said that BASIC knows where the stuff is at the routines are at 0, 3, 6, 9, 12, and 15. So this is the routines, the address to where you can find the routines. The routines will, whenever you recompile the program, will calculate here. So the first thing that comes from BASIC, it will do a jump subroutine to one of these addresses. Okay, if it's the init routine, it will jump here, and the first thing it will do, the first thing is a jump instruction and where that routine is located. This is not common stuff we've been doing before. So when we say do the init, it will do a jump to h init. We'll go down here to h init, and the first thing it does is does a branch to a subroutine. Remember this is our stub program. This is our router. So it's got a lot of may look like some confusing, redundant stuff, but it's not. First thing it wants to do is go to subroutine number 1. Subroutine number 1. It pulls the return address where it just came from off the stack and stores it in a common place at a return down here at the end of the program. It's going to store it down here. Okay, so it'll know how to get back to where it's going. Okay, it will also save the current stack. Okay, we need that stack so once we get back to normal, and it will load up a new address for the stack. The new address for the stack is right up here, new stack at E00. And remember when you say that, well, that's on top of code. No, because the stack goes down. when you say stack, push on a stack, it goes down. The first thing you put in a stack would go down to DFF. So we've loaded up a new stack address. Now here's one of our macros we talked about in the last lesson. Interrupts off, and it drops out this code to ORCC. It disables interrupts. Another macro, task 1. It's going to put us in task 1 mode. So all that other stuff was in memory now out, and all the graphics screen information, including our block 33, is in memory now. So we do that. We load up our return address that we just saved up here and push it on a stack and return. We'll use that address, going to return to it. Where does it go to? Well, here was here. We did a branch subroutine. It's going to branch right back to here. And that's now we're going to do a jump subroutine to an indirect to someplace called h-init. Okay, I'm sorry. Yeah, h-init. Okay, h-init. Look up here in our thing. Is our equates is at 9800. Okay, 9800. Remember, that's the top of that graphic screen. That's where our code at. So our first init routine is at 9800. All right, let's go over to the main program. All right, this is the main program. Okay, it also has the same includes, so everything's in both programs. Okay, this is all the same equates in this program as in the other one, and here we are at 9800. And this got the address where our init routine is at 9808, right, which is right here. So I want to go through this here code as we go along and hopefully understand it. It's not rocket science, but it probably gets confusing. We've been branching and jumping and branching and jumping. A note here, all below defaults are the same for all boxes, okay, because they're all the same size. We got 64 of them. Now, if you were doing something else that had, say you had 10 or 12 sprites and they were of different sizes, then you couldn't knit them. We're knitting everything to the same here because that's why the boxes are all the same size. So we load up our screen width. We store it in a place called temp.scr. Okay, again, we have a structure here. Okay, temp, which is TP, and TP, here's our structure. Box number 1, buffer 1 address, box 2, and the address of buffer 2, the screen width. Okay, this is set up. We always know it's going to be 320, but if you was working with another program, you could use the same code if it happened to be a 256 widescreen anyway. So it's just a thing is screen width, and then what does each one of these boxes is, how many columns wide, which in this case are 22 pixels and 15 pixels deep. Okay, so we're going to init all that stuff. We're going to screen into temp screen, the box width and the temp column, the height and the temp row, and store all that stuff. Now here's another new piece. We're going to load up A with a block number, page number 34, and we're going to put in FFAE. All right, let's go back, and where are we at here? I've lost my page here somehow. Okay, I found my correct page. Okay, so what we're doing is taking block 34 and we're going to put it up here where right now it's got block 35 in it. Okay, at address C00 to DFFF. Okay, block 34 is what BASIC uses for when you use the HBuff or the HGet, HPut, it uses block 34. And we're going to use that block 34. And why do we want to use it? Because I looked at it and their code for their buffering is good. It's good code. It works good. They've got all the buffers chained together, so we don't have to write any chaining code. It's efficient, and we're only going to go there one time, so it doesn't make any difference. Now, if you do the HGet and HPut over there, their code does a lot of back and forth with floating point numbers and that, so we're going to do our own HPut. And we're going to, again, let me slow down. We're just going to use their block 34 and their buffering, which we allocated them in BASIC. So we put 34, we stored in there, so we bring it in at C00. We load up buffer number 1 because we're going to be using buffer 1 and buffer 2. We load up buffer 1 in B, and we jump subroutine into super extended basic at EF18, and it will find the buffer for it. It goes through the chains and finds the exact buffer where it's located at and stores it down in lower memory at CF. Okay, so we'll load Y with CF and we'll store Y into temp.buff1 address, okay, which is here. So now we've got wherever we need that buffer address, it's stored right there. We don't have to go back there again. Now in here we'll put 2 in the B. We'll go off to the same routine, come back, get the address for buffer 2, and we'll store it in our structure. We'll load up 35, store it back in to restore back it. When we put 34, we'll go 35, and we'll do a return sub. A return sub, where does that go? Remember, that goes back to our stub program init. Okay, we did a jump sub to init. It comes back. Now the first thing when it's back, it does a branch subroutine to sub 2. Sub 2 is the cleanup part of this routine. 1 gets you organized where you want to go, saves all this stuff. Sub 2 is going to set it all back to normal. Again, we'll take our return address, we'll store it, we'll go back to task 0 with our macro that puts us there. Up here we saved our stack. Down here we're going to restore our stack. We'll load up our return address, we'll push it, we'll turn the interrupt back on, and we'll return back from sub 2, which is right here. This next instruction is return sub, returns us back to basic. Right, we go all the way back there, we'll go back to basic here. Okay, we went there, here's our set, here's when we did it. We went here to our defaults, it would come back here. Each one of these is the same or similar. Okay, we're going to go out, we're going to do a get buffer 1, get buffer 2. All right, we need to go through these. They're not that long, but we'll go through them just so how some of the differences is in them. All right, here's a stub program, which we have hget1. Okay, when we come from basic, it also brings the pointer to the box number. All right, you recollect, okay, over here, we got our box number 1, we converted it, well, we got a string now, and right here, go user 1 with this variable pointer. So we go back to our code, and okay, did I go too far? No, we're in the, I'm sorry, we're here in our stub program, X has the pointer to that variable that we're passing. We load 2 off of X as the actual pointer. We did this in a previous lesson. You may have to go back and review that. And that points us to the exact string it passes us. And the very first thing in the string is, I believe, is the string length. So we're going to bump it by 1. Now we're pointing to the exact string. If we typed in 33, we'd be looking at that string, and it would be hex 3333 for 33. Or if it was 0, it would be hex 30. Anyway, we need to convert that back to we need to convert it to a hex number because now we got a string. So we're going to a routine here called decimal in. Input is in register X. This is something I wrote probably 20 or 30 years ago, but anyway, it still works. Input register X is pointing to the input string or the message, and your output will be in register D. Here's an example. If you come into it with a string of 1, 2, 3, 4 character format, your output will be 4dog2. So it's going to convert. So if we come in with, say, 63, it will come out with 3F in register D, what we want. You can decode this routine. It's been working for 20 or 30 years, I know at least. So if you come in with X with a string, it will go until it finds something that's not numeric. So if you come in with 123.45, it will go up to the dot and quit. If you come in with 12AB, it will go to 12, and if it's A, it says that's no good, I'm out of here. So It will go until it finds something that's not 0 through 9. Okay, now all that code and stuff is in there. You can decode it yourself. So we did that. Now we come back and that has our box number and hex number, and we'll store that box number in our structure in box 1. We'll branch subroutine to sub 1, which we did before. We don't need to decode again. Remember, that's where we set everything up and went off to our routine in the main program. So we will go up to the main program to get one, or it's get. We only have one routine over here for a get routine. Okay, we'll get our box number. We'll load up that 34 again and puts it at C00. And okay, now that, once we do that, we have our memory set up the way we want it. First thing we're going to do here is, I'm sorry, we did one thing. I need to go back one page. I got too fast there. We were here. We need to subroutine 1, we did that, and then we need to load up Y with buffer 1 address and the box number. I'm sorry, we need to load them, and then we go to HGet. We get over here, it's looking for the buffer address in Y and the box number in B. Sorry, we did that wrong. So we'll save the box number, we'll get our buffer area, and what we're going to do is take the stuff off the screen and put it into the buffer. Okay, Y is pointing to it, but before we do that, we're going to take some information, the screen width, and store it at Y and bump it by 2. We're going to get our column, which is the width of it, and we're going to store that in Y, and row, and we're going to store that in Y. Why are we doing that? Because when we pull it back out of the buffer, all that information will be there. Like I said, if you were doing many sprites of different sizes, all the different sizes, that would be stored in there, in these areas. So we're going to put that into the buffer area first of all. Then we're going to load our box number back up, and we're going to go to a routine called calc address. This may be one of the last routines we really have to look at. Okay, we're going to calculate the screen address based on a box number. Okay, now I'm going to go through this whole routine, and then I'm done. I'm going to tell you there's probably a better way to do it, but that's okay. This is the way I coded it, and I decided that it's done. I'm not going to change it. So come with box number in B, and we're going to return with the address on the screen in register X. Now there's a lot of code in here, and if you want to know what it's doing, you go up to the front. I've kept all my notes in here, and I do this when I code a lot. And it says, yes, it's confusing. But anyway, here's how you calculate the box number. Okay, and it's all in here. And here's an example of box 0 and box 17. And when you calculate, here's the address you get, and here's the address you get. I use this here. I did this on paper, and I got it all figured out. And when my calculations was done, they came back to this. The difference is the things that it gets somewhat confusing. Try not to, but it does get some confusing. It is when you get to, I'm sure having problems with screens here, when you get to these boxes here. Okay, a box number has a dimension in this upper left hand corner to this lower right corner inside the lines. That's one dimension. Okay, inside the lines, 22 pixels wide, 15 pixels high. That's inside. But to go from box to box, it's go from this upper corner, this pixel, to this upper corner pixel. You got to add these other 2 pixels in here. So it's 24 pixels wide. You go from this pixel here down here, it's one extra, it's 16. So you got 2 different dimensions. You got to remember that when you're calculating. Once somebody tells you that, once you learn, it's okay. But trying to figure that stuff out at first, it gets a little confusing. But anyway, that's the calculations up here. Tells you all about it. And then when you get down to the actual calculate the address, you can see what we do. We've got a table in here, load extra table. Here's the table. Box 0 is in column 0, row 0. Box 8 is like in column 0, row 1, so on and so forth. So there's 64 bytes here, or each one, when you get down to 63, it's in column 7 and row 7. And just going through, and you know, this is something you need to doing your own, you can learn. I mean, this is just normal calculation stuff, just multiplying, shifting, and multiplying, adding our screen 2000 at it, and you end up with their address. Okay. Oh, I think there's a better way of doing it. I think if I would have come in here instead of having this table, if I just come in here and did a division, one division, I could have come up with basically these two addresses I needed and did the calc. Anyway, this works. Use it or don't use it. Where was it? We was on the we calculated the address, and now again, this is stuff we've done before. We got the box height and the width. Okay, it's 8 by 8. And we're going to loop through. Go through very. We're going to go through. Start in that corner. We're going to go save this to the buffer. 8 pixels, or these 22 pixels, or 11 bytes. We're going to drop down a row and back up here and get this. We're going to do that 15 times. That's all that routine is. Okay. Again, you can debug it. It works. Okay. And when we're all done moving all that stuff out into the buffer, we're going to go 35, restore that, and then go back to the caller. The caller being the stub program, which was get 1, goes back to stub 2, restores everything back, and we're done. The only other thing we need to probably look at is the put routine, which is, here's one I want to tell you one other thing too. HGet1 and HGet2, they're exactly the same except for this is box 1, buffer 1, box 1, box 2, buffer 2. Now, you could say, well, I could maybe do something different. If you had 20 different items, yes, I would say you could modify the code on the way in or have some routine that says it was if and or do this. Here with just few instructions, I just let it, they're the same thing other than these box numbers. So it takes a lot more code than it does this code here. Same way with the HPut. They're the same, but you take a lot more instructions to break this out into determining where you're at. All right, quickly try to get through this thing. HPut does a sub 1, load up our buffer. Okay, if you look at this now, we're going to load up buffer 1 address and box 2 number. Okay, and we're going to go put it on the screen. Okay, this is the flip. We're going to take what's at buffer 1 address and put it where box 2 was. Down here at put 2, we're going to take buffer 2 address and put it where box 1 was. So let's look at HPut. HPut's pretty simple. Same thing as the other one. Get a box number, go calculate the address. We just talked about that. To calculate the address, bring back in our block 34 and pull all that stuff we put on originally, the screen width, the box width, the height, and all the variables, and push them on the stack, and then go through I equals 0 to 7, j equals 0 to 7, and go through the loop and put it all back on the screen. Now, if you look at the code of this one and this one, I put it in 2 different ways. This one's push everything on the stack and work it out of the stack. Okay, this here was other working a different way. So you can look at the 2 ways and see here's 2. Because remember, most things when you code stuff, there's more than one way to do it. Some things are more efficient, some are quicker, and some take less room. There's 2 ways. You be the judge, okay? All this is puts it back on the screen and goes back into the stuffer back to basic, and we're done. So that's all of it. I hope I didn't leave anything out. Okay, again, let me get back to here. Remember this was a concept. Okay, how to use it. This may not be the best thing. I figured that this was kind of easy code. Hard as it was to explain and talk about, it was still easier code for understanding. Work with it, try it, get some creative juices flowing and say, oh, I know I could use that for sprites. Or if I just have a place on the screen, I want to keep changing colors on a window or a background or whatever, you could just, okay, and it doesn't, and you're running out of memory or you need something faster, you can do it here. Okay, I'm going to do one more for the road, if I may. Okay, I'm back over on the test screen. I'm going to do 88 again, and you can see it flipping through the numbers. Okay, that's what all this thing does. All that code and all that talk, that's all it's doing is flipping them. Remember now, it has no idea what's in the box. It doesn't know that's box 57. It just knows it's a box number. And whatever in that box number, it's going to put it into another box. And it doesn't know anything what's in it. It could be a different sprite inside there. It could be a different character. It could be alpha character. But anything. It doesn't care. Okay, it's just whatever in the box. So, and if I do a 99, it will restore us back, and we are really, really done this time. So I don't know. I'm thinking about maybe at some point in time doing a part three, and using some code that maybe if you understand this, we'll do some more code that will actually put it out in its own page. I put it out here in the graphics page to give you an idea on how you can move stuff around. I try to make these things easy but something complicated, but different ideas in there, because that's all it's about, is just ideas that you can use, and hopefully that the light bulb will come on. You say, okay, uh, different sizes. I'm looking at my notes here. Maybe a part three. And in most of this stuff, there's more than one way to code a lot of this stuff. Okay, so that's up to you if you come up with a different way. I'm not saying my way is always the best, but I'm getting it done and trying to show you how to do different things. So anyway, I'll quit rambling on because this is probably going way too long anyway. So I don't know if we're at the end of this series or not. I'll try to get a part three someday, but no promises. So with that, I'm out of here. Thank you.